Hello everybody, welcome to my AP Physics 1 final project free response question analysis. For this analysis we're going to be analyzing the 2015 AP Physics 1 free response question that is focusing on Attwood machines. The question states, two blocks are connected by a string of negligible mass that passes over a massless pulley that turn with negligible friction. As shown in the figure above, the mass M2 of block 2 is greater than the mass M1 of block 1. The blocks are released from rest. The first section of this problem is asking us to draw a free body diagram. It states, the dots below represent the two blocks. Draw a free body diagram showing and labeling the forces, not the components, exerted on each block. Draw the relative lengths of all vectors to reflect the relative magnitudes of the forces. To start off, we need to find the forces exerted on each block. Block 1. We know that it is experiencing a force of gravity. The force of gravity is equal to the mass of the block, which is M1, times gravity, which is negative 9.81 meters per second acceleration. The other force exerted on mass 1 is the force of tension on the rope. The force of tension on the rope has to be greater than mass 1. We know this because mass 1 is moving in the upwards direction, because the force of gravity of mass 2 is greater than the force of gravity of mass 1. For block 2, the free body diagram is a little bit different. We know that for block 2, the force due to gravity is greater than on block 1. So we can find that Fg2 is equal to m2 times g. However, the tension on block 2 is equal to the tension on block 1. This is because the force of tension does not change throughout each block, since it is in a system. We know that the rope is not experiencing a different force of tension on either side. These are the free body diagrams you should get. You should get that the force of tension for each free body diagram should be equal, represented by the dash in between them. You should get that the force due to gravity of the first free body diagram for block 1 should be the smallest or the shortest arrow of all of them, because it is the weakest force. And finally, we should get that the force due to gravity exerted on block 2 is the longest of all of the arrows, because this is the greatest force exerted, the block. We know this because the block is moving downwards. Now that we've drawn the free body diagrams, we can move on to Part B of the free response question. Part B asked, derive the magnitude of the acceleration of block 2. Express your answer in terms of m1, m2, and g. We can find the magnitude of block 2. To start off, we have to separate block 1 and block 2, and solve this in parts to make it easier. We know that force is equal to mass times acceleration. We know that the force of tension for block 2 is less than the force due to gravity. We know this because the block is moving downwards, and the force tension is not enough to counteract the force of gravity and cause for the block to be in equilibrium. Because of this, we can represent force, or net force, as m2g, which is the force due to gravity, minus force tension, which is equal to mass 2 times acceleration. For block 1, we can still use the force equals mass times acceleration, or mass times acceleration equation. We know that the tension experienced on block 1 is greater than the force due to gravity. This is because the block is moving in the upward direction. if the block is moving in the upward direction, as shown by the free body diagrams, and the force due to gravity is less than the force due to tension, the block will be moving upwards. We plug this into the equation as force tension minus mass 1 gravity, which is the force due to gravity. That's the net force on block 1. Is equal to the mass of block 1 times acceleration. For the final part of this, we're going to use basic algebra to combine the parts of this equation. We can take this section, and this section, and this section, and set them equal to each other. For the system, to solve for the acceleration of block 2, we get mass 2 times gravity minus mass 1 times gravity equals mass 2 times acceleration due to gravity plus mass 1 times acceleration due to gravity. We can further simplify this by taking the components of A, and we get m2g minus m1g equals A times mass 2 plus mass 1. And for the final step of this equation, to solve for A, we have to divide by m2 plus m1. This will give us the answer. So will give us our final answer. A, acceleration of block 2, is equal to m2 times gravity minus m1 times gravity over mass 2 plus mass 1. You can check your answer to make sure that it is correct, or that it doesn't have any wrong pieces, by rereading the question. The question states to express your answer in terms of mass 1, mass 2, and gravity. Our answer has no tension in it, as we got rid of tension during this step of the equation, where we simplified the two different blocks into this final result. After simplifying the equation further, we came to the final result that acceleration is equal to mass 2 times gravity minus mass 1 times gravity over m2 plus m1. For the third and final section of this free response question, it asked, block 3 of mass m3 is added to the system as shown below. There is no friction between block 3 and the table. Therefore, we still no longer have to worry about any friction between any of the surfaces or the weight of the rope. The question states, indicate whether the magnitude of the acceleration of block 2 is now larger, smaller, or the same as in the original two-block system. Explain how you arrived to your answer. We can solve this by using the equation force equals mass times acceleration. There is the same net force in the system, so force net is not changed. It's still equal to m2g minus m1g. However, the mass of the system has changed as block 3 has been added. So we see that the force net is now equal to mass 1 plus mass 2 plus mass 3 times acceleration. The addition of this third mass will reduce acceleration. We know this because acceleration is equal to force over mass. Mass is the denominator in this equation, meaning that an increase in mass will have a reduction in the final result. This makes sense, because if you want to have the same force, the acceleration will have to be reduced in order to compensate for the larger mass. The final answer for this question should be something along the lines of, there is the same net force in the system, but the system has more mass. Therefore, the acceleration must be reduced. So, we know that the acceleration in the system is reduced. Again, this is because acceleration equals force over mass. An increase in mass will result in a smaller acceleration. We also know that the net forces are the same, as block 2 is not being affected by gravity in the system because the table is counteracting the force of gravity. Remember, there are always different paths you can take in order to come to the same outcome. Be sure to think out and plan through how you wish to attack this question. If you get stressed and flustered, just take a minute to calm yourself down. It can only help you out in the long run. Good luck on your test, guys.